Hello students, in our last class we have discussed chemical reactions of alcohols, and in chemical reaction of alcohols we have discussed reactions involving due to breaking of oxygen hydrogen bond. So in today's class we will discuss chemical reactions involving due to breaking of carbon oxygen bond. So our heading is reactions involving breaking of carbon oxygen bond of alcohol. Okay, so the first reaction is number 1, reaction with phosphorus halides, as for example PCl5 and PCl3. Okay, suppose we have taken ethanol. And when ethanol will react with PCl3, that means phosphorus trichloride, then the OH group is replaced by chlorine atom to give C2H5Cl, and after that the side product is H3PO3. Okay, and next again suppose we have ethanol, and in this case we have taken PCl5, that means phosphorus pentachloride. Again in this case phosphorus pentachloride is chlorine rich compound, and that chlorine will replace the OH group, and the result is C2H5Cl. But in this case the side products are different, and the side products are POCl3 and HCl. So about this reaction you have already studied in chapter 10, that means preparation of haloalkanes, and this one is chloroethane. Again this one is chloroethane. So you have already studied about these reactions. And then the next reaction is number 2, reaction with thionyl chloride, and the formula of thionyl chloride is SOCl2. That means suppose we have again taken C2H5OH, that means ethyl alcohol or ethanol, and ethyl alcohol is reacting with thionyl chloride, but the reaction is carried out in presence of pyridine. Okay, and then in this case also chlorine is present, and the chlorine will replace the OH group, resulting C2H5Cl, and after that the side products are sulfur dioxide and HCl. So you have all again study about this reaction in unit 10. And now another example is, and most important reaction of this chapter is dehydration. Now we will study dehydration of alcohol. Therefore number 3, dehydration. So always remember that alcohols having beta hydrogen, this carbon is alpha carbon because with this carbon the functional group is attached. The carbon having the functional group is known as alpha carbon, and after that the next carbon is called beta carbon. Okay, and alcohols having beta hydrogen, in this case in the beta carbon 3 hydrogens are present. So alcohols having beta hydrogen are when heated with concentrate H2SO4, okay, at 443 Kelvin temperature, then the OH group will lose from the alpha position. Okay, we are writing the OH group here, again one hydrogen here. Okay, that means the OH will lose from alpha position and the hydrogen will lose from beta position, and they both combine to form water, and then the main product is CH2 double bond CH2, that means an alkene. Okay, so we are converting ethanol into ethene. Another example is, suppose we have take CH2 CH2 CH2OH, and then we have apply heat in presence of concentrated H2SO4, then from the alpha position OH group will removed, and from beta position hydrogen will removed. That means the product is CH3, after that CH, and then double bond, and then CH2, and the OH and hydrogen will combine to give water. So we have converted propane 1-ol into propene. So this one is another example of reactions involving breaking of carbon oxygen bond. In this case the carbon oxygen bond is breaking. Okay, and then we will study about oxidation of alcohols. And in organic chemistry, oxidation means either addition of oxygen or removal of hydrogen. And during oxidation of alcohols, generally hydrogen are removed. Okay, suppose we have this alcohol, suppose this one is CH3 CH2OH, and during oxidation always remember that this this oxygen hydrogen bond will break, and then this carbon hydrogen bond will break. That means hydrogen will remove, and after removing hydrogen, here one double bond will form to satisfy the valency, hence the product is this one, that means aldehyde. And when we will take this one is primary alcohol, that means during oxidation of primary alcohol aldehyde is formed. Okay, suppose we are taking one secondary alcohol, okay, and during oxidation of secondary alcohol always ketone is formed. This one is ketone. Okay, and now we will see, or we will take the examples of oxidizing agents. First, remember the oxidizing agent is chromium trioxide, and then K2Cr2O7 potassium dichromate, either acidified or K2Cr2O7 alkaline. Alkaline or acidified solution of potassium dichromate is an example of strong oxidizing agent. And then we will use KMnO4, either acidified or alkaline, KMnO4, potassium permanganate. Okay, then one oxidizing agent is PCC, pyridinium chlorochromate. Okay, and this one is selective oxidizing agent. This oxidizing agent do not oxidize carbon-carbon double bond. Okay, so we can take example of these oxidizing agents to oxidized alcohols, but always remember that these two oxidizing agents are very strong oxidizing agents. These are very strong oxidizing agents, and when we will use these two oxidizing agents, then primary alcohols are finally converted into carboxylic acid. Only aldehyde is the intermediate product. At first, alcohol converted into aldehyde, and then the aldehyde is converted into carboxylic acid. Okay, always remember that. Therefore, generally these two oxidizing agents are not used to oxidize primary alcohols. So now we will take examples of some oxidizing reactions. Okay. So our heading is oxidation. As for example, suppose we have take CH3, CH2 and then OH. Okay, here the oxidizing agent is chromium trioxide, and then CH3, CH, OH, CH3. In this case we have, or we are using KMnO4. Okay, and number C, suppose CH3, CH, double bond CH, CH2OH, and in this case we are using PCC. Okay, and we have already learned that during oxidation this oxygen hydrogen bond will break, and here another hydrogen will remove, and the result is CH2. Initially CH2 was present, now CH, and then this hydrogen will remove to give O, that means aldehyde. Okay, and in this case the product is CH3C. This hydrogen will remove, again this hydrogen will remove to give double bonded O, that means ketone. And in this case I already told you that PCC, that means pyridinium chlorochromate, is an example of selective oxidizing agent, and it will not oxidize the carbon double bond. It will oxidize only the primary alcoholic group, and the primary alcoholic group will convert it into aldehyde. So these are the products which are formed during oxidation of these alcohols. Okay, so this one is ethanol and this one is ethanol. Okay, this one is propane 2-ol and this one is propanone. Okay, and this one is 1, 2, 3, 4, that means but 2 in 1-ol. and then this one is but 2 in Al, in L, because aldehyde is present, therefore you have to add Al. In this case alcohol is present, that means OH group is present, hence we have to add OL. So we are taking example of oxidation reaction. Now let us consider a tertiary alcohol, and what will happen if tertiary alcohols are oxidized. Okay, suppose this one CH3C, CH3, CH3, OH. Okay, in this case oxygen hydrogen bond is present to break this bond. Okay, but carbon hydrogen bond is not present, therefore tertiary alcohols are not oxidized by weak oxidizing agents. But when we will use acidified KMnO4, strong oxidizing agent, then initially the acid will help to form an alkene. Okay, that means from this carbon OH group will removed, and from this carbon one hydrogen will removed, resulting carbon-carbon double bond, and then finally the KMnO4 will oxidize this compound into a ketone. This one is ketone, CH3, C double bond O, CH3, and this portion will convert it into carboxylic acid having one carbon atom. Okay, so always remember that tertiary alcohols are not oxidized by weak oxidizing agents, but strong oxidizing agent like acidified KMnO4 oxidized tertiary alcohols into alkene, and finally mixture of ketone and carboxylic acid is formed. Okay, so we have studied about oxidation of alcohols. Okay, now we will discuss some exclusive chemical reactions of phenols. So our heading is chemical reactions of phenols. The first one is number A, nitration. Okay, so we are taking the phenol, and for nitration we are using dilute HNO3. Suppose one student is using dilute HNO3 and another student is using concentrated HNO3, that means concentrated nitric acid, and they both will get different products. When dilute nitric acid is used, then two products are formed. One is orthonitrophenol and another is para-nitrophenol. This one is orthonitrophenol and this one is para-nitrophenol. Okay, this position is known as ortho position. Both these two positions are known as ortho position, after that meta position and then para position. In this case the nitro group is attached with ortho position, therefore orthonitrophenol, and in this case the nitro group is attached with para position, therefore para-nitrophenol. Okay, but when concentrated nitric acid is used, then three nitro groups will attached with the aromatic ring, and they will attach at the ortho positions and para position, and this compound is known as 1 2 3 4 5 6 2 4 6 trinitro. 3 nitro groups are present, trinitrophenol or picric acid. Okay, so we are taking examples of chemical reactions of phenols, and at first we have studied about nitration, and then the next example is bromination. So number B, bromination. So at first we are using bromine in presence of carbon disulfide. Again we are using bromine in presence of water, that means bromine water. Okay, and in first case the bromine will attach to the ortho position and in another compound to the para position, and then when bromine water is used, then 3 bromines are attached to 2 ortho positions and at the para position. So you have to remember these reactions also, because these are very important along with the nitration. In exams questions are asked from these chemical reactions. Okay, so questions asked like complete the following reaction. Phenol is given along with bromine water, and what is the product? So you have to write this product. Okay, and always remember that this para product is major product. Always para product is major product and ortho product is minor product. Okay, so we have again studied about bromination of phenol, and now we will study another important reaction of phenol, and that is Reimer-Tiemann reaction. So our heading is number C, Reimer-Tiemann reaction. Reimer-Tiemann reaction, and in this reaction phenol is treated with chloroform CaCl3 and then sodium hydroxide, and after that with an acid. Okay, and then in the product 1 CHO group is attached at the ortho position, and the product is known as salicyldehyde. Okay, one important name reaction which is always asked in exam. So when phenol is treated with chloroform in presence of sodium hydroxide, and after that acid hydrolysis, and then we will get salicyldehyde. Okay, and this name reaction is known as Reimer-Tiemann reaction. And our next reaction is Kolbe's reaction, another important name reaction, that is Kolbe's reaction. Number D, Kolbe's reaction, and in this reaction phenol is treated with carbon dioxide in presence of sodium hydroxide, carbon dioxide in presence of sodium hydroxide, and then this carbon dioxide will attach with the benzene ring or aromatic ring at ortho position, forming salt. Okay, that means salt of carboxylic acid. And after hydrolysis, and when salt is formed, always remember that we have to do hydrolysis. And after hydrolysis, the product is salicylic acid. Okay, this reaction is also important for exam purpose. And then the final reaction of phenol is reaction with zinc dust. That means phenol is heated with powdered zinc. And then number E, reaction with zinc dust. In this case, the phenol is heated with zinc. Okay, this one is Z and zinc, and the zinc will get the oxygen atom of phenol, and the phenol will convert it into benzene. Therefore, the product is benzene along with zinc oxide. So this reaction is also known as reduction of phenol. That means the phenol is reduced to benzene. So in our today's class, we have discussed at first some chemical reactions of alcohols. Okay, in chemical reactions, important reactions are oxidation of alcohols and dehydration of alcohols. And after that, we have studied about exclusive chemical reactions of phenol. So we have completed about alcohols and phenols. In our next class, we will discuss about ethers. So that's all for today's class. Thank you.